finding the equation of a tangent line and normal line. That's what we're going to be doing in this lesson. So in order to find the equation of any line, we need two things, a point and a slope, right? We just discovered that, and most of you should have known it from the past also. So the point, usually the x coordinate is given to us, and then we can always find the y coordinate, right? And for the slope, we use difference quotient here, which is this, right? We're all very well aware of it, how to apply it. So let's use this to do our example 1. So in example 1, it says find the equation of the tangent line. Okay, so I know I'm going to find the equation of a tangent line. And the function is given to me at x equals -5. So I know I need two things, point and my slope. So let's talk about the point. I only know my x coordinate. I can find my y coordinate if I substitute -5 in for x, right? And that'll give me my y coordinate. So -5 squared is 25 plus 1 is 26. So my point is -5 comma 26. So that is the point. And now I need my slope. Using my difference quotient, I'm going to find my slope. So first of all, let's find our this is our f of x. I'm going to find my f of x plus h, right? So substitute x with x plus h. We all have been expanding this, right? So we should all be very good with this. This will be x squared plus 2hx plus h squared plus 1, right? So now all I'm going to do is substitute, I'm going to substitute this with this, and then also I'm going to substitute my f of x with this. So I'm going to do that. So it's going to be m equals limit as h approaches 0, x squared plus 2hx plus h squared plus 1 minus, remember there's a minus sign, so if I was to distribute that minus sign, this whole thing will become negative, right? All over h. I'm going to cancel out my ones and my x squares, they cancel out. Now if I was to apply the limit here, or I was to substitute h with 0, I get a 0 over 0, which is what we don't want or we can't have. So what do? I'm going to factor out my h, and I'm going to be left with 2x plus h over h. What happens here? My h cancel out, so now I don't get a denominator of 0, right? I can avoid that. And now I'm going to substitute h with 0. So I get what? 2x plus 0. So this is it, right? At x equals -5. I want to find the slope at x equals -5. So I'm going to substitute -5 in for x. I get my slope to be -10. So that is my slope. That's my slope, -10. But I'm not done. I need to write the equation. So all I need to do is put my slope and use my slope and my point in this equation, and I'm good to go. So this is what? Let's write this down. Let's label it also. So this is the equation of my tangent line. Oh, I don't have to write my tangent line, right? Or line tangent to this curve. So it's going to be y minus y1 was what? 26 equals m, which is -10, x minus x1 is -5, right? You can leave it in this form. I'll just simplify it further. If you want to solve it for y, you can go ahead and do this, right? But we can leave it like that. So I'll be fine. I'm going to box this here, and I'm going to say I'm fine. If you want to solve it further, I'll just do it so that we all understand what we're doing. Y minus 26 equals -10x will be what? -50, right? So when I substitute in, sorry, not substitute, add 26 on both sides, I get what? -10x minus 24. So that is the equation. So these two equations are the same actually. So I'm fine with you leaving the equation in point slope form. You don't have to simplify it further. Not solving it for y is absolutely fine. Example 1, we dealt with the equation of a tangent line to the curve. So I'm just going to demonstrate with this picture. So this was your curve, right? I'm going to do it in black. So this is your curve, right? And then you actually, for example 1, we found the equation of this line that was tangent to the curve. Now, what is a normal line? The normal line to a curve at a given point is the line perpendicular to the tangent line at that point. So this is your normal line. So what's the relationship between your normal and tangent line? That they are perpendicular means, what do you know about their slopes? Their slopes are going to be negative reciprocals. And that will help us find the equation of this line, the normal line. And let's do example 2 and we'll figure it out from there. Okay, so example 2, find the equation of the line perpendicular to the curve y equals x squared minus 3x minus 1 when x is equal to 5. Again, we need two things to write the equation of a line, which is a point and the slope, right? Our point, we only know our x coordinate if we substitute x equals 5 into the equation. So our y coordinate is going to be 9. So I know my point is 5 comma 9, right? We're just substituting that 5 in place of x. So this is my f of x. I know that I can find my slope using my difference quotient, right? So first, for that I need to know my f of x plus h. So I'm going to find my f of x plus h. So I'm going to do it here. F of x plus h is what? X plus h square minus 3x plus h minus 1. Oh, minus 1. Right? Expand it. X plus h equals, this will be x square plus 2hx plus h square minus 3x minus 3h minus 1. So that's what we got here, right? So now I'm going to just do is what, substitute in place of f of x plus h. I am going to write, this is my f of x plus h. I'm going to copy this whole expression over there, right? So let's do that. My slope m limit as h approaches 0, x squared plus 2hx plus h squared minus 3x minus 3h minus 1 minus this whole thing, right? So what will that be? Minus x squared plus 3x plus 1. I hope we all understand we distributed the negative, right? All over h, right? So let's see what cancels out. My 1's cancel out. 3x, negative 3x, negative x squared, positive x squared. So now, what do I do next? Look at this. If I substitute h for 0, I get a 0 over 0. We can't have that. But I do see that h is common in my all three terms in the numerator, or it's my GCF. So I'm going to factor that out. Minus, oh, it's, my bad, it's just h, and then it's 8, I just factored out, right, over h. What happens to my h's? They cancel out, right? So what am I left with? I'm going to apply the limit now. I'm going to substitute h for 0. I'm left with 2x plus 0 minus 3. So what do I get? I get 2x minus 3. I want to find the slope at when x is equal to what? 5. So my slope would be 2 times 5 minus 3. So my m is equal to 7. 2 times 5 is 10. 10 minus 3 is 7. Okay, so 7 is the slope of the line that's tangent to the curve, right? So if this was my curve, I'm just going to sketch it here. And I'm going to change colors. So at this point, let's say the point was what? 5, right? So the slope of this line in blue is, I'll write that, is 7. But what am I looking for? I need the equation of the line that's perpendicular to it. So what do you know about the slopes of lines that are perpendicular to each other? Right, they're passing through the same point. What do you know about the slope of the red line? It would be, yes, it is negative reciprocal. You should have taken the cue from there, right? So let's call this M1. The slope of M2, or my red line, would be the negative reciprocal of it, which is negative 1 over 7. But I'm still not done. I need the equation of this line, right? I need the equation of this red line. So the point slope is y minus y1 equals m times x minus x1. I already know my y1 and y2, sorry, x2, y1 and x1. So it's going to be y minus 9 equals negative 1/7 x minus 5. And that could be left in this form. If you want to solve for y, please go ahead. But I think I'm just going to leave it in this form. Point slope